To try to calculate the equation of horizontal asymptotes, or more precisely figure out how a function is behaving at the ends, we are going to study one example here, 1 over x. You should have seen this graph before, and we have certainly talked about it in terms of the vertical asymptote that's happening at the origin. Today we're going to look at the ends. We are just going to use the graph. We are interested in the limit as we go out to either infinity. Now note, we cannot use the limit laws, and that's important here. If you were to take the limit of 1 over x, and if you were to sneak a peek, you would see 1 over infinity. And in order to use the limit laws, you have to have all of the constituent limits existing. That limit does not exist. You cannot use the limit laws directly. In this case, we are going to use the graph, and we are just going to state this as fact. The limit of 1 over x is 0 as I go very far out to the right, and similarly, as I go very far out to the left, it's also 0. You could do analysis if you wanted to do this without the graph, but it will take you to the same conclusion. These two results are really important for us. And as soon as we have these results, we can do a lot of piggy banking and go from there. Now, the limit of 1 over x squared as I go out to infinity. If you were to sneak a peek, I see a 1 over infinity. That means the limit on the bottom doesn't exist, and that means I can't use the limit laws, right? Can I use the limit laws? Yes. And now you're really confused. How can I use the limit laws? I thought you just said if the limit doesn't exist in the bottom, that infinity, how can I use the limit laws? You have to be smart. And this sets the strategy for this whole entire section. So the idea is that you write it in terms of limits that you know exist. And when we start going out to infinity, we know that this limit exists. So we are going to put the expression in terms of 1 over x. And that becomes the game plan in this strategy. When I have any sort of algebra limit, I have to do a little bit of rewriting. This is 1 over x all squared. Since the limit as x approaches infinity of 1 over x exists, it's equal to 0, the limit laws now say that I can be smart and write the limit like this. This is a proper use of the limit laws. And because this limit exists, I'm justified in using the limit laws in this way. This is going to be our strategy going forward for most expressions. When I see a limit, 3x squared plus 4 over 5x squared minus 1, I am going to calculate its limit using the limit laws. The first thing I should always do when I see a strange limit is sneak a peek and say, look, when x gets really big, what does the numerator want to do? The numerator wants to go to infinity. When x gets really big, what does the denominator want to do? The denominator wants to get to infinity. You can't use the limit laws directly here. You need to do some sort of algebra, and you're going to rewrite it in terms of 1 over x so that you can use the limit laws. And in questions like this, when you've got rational functions, so polynomial over polynomial or things with powers of x, it actually becomes pretty straightforward to do. You're going to divide the top and the bottom of this expression by the highest power of x in the denominator. If the limit is going to work, this is the strategy that will get you to the answer. When I look at my expression here, the highest power of x in the bottom is x squared. So I'm going to take my limit, I'm going to take the top and divide it by x squared, and then I'm going to take the bottom and divide it by x squared. Now, there are other ways to think of it. You can think of it as factoring things out. However you want to think of it, you're going to end up with a new expression. When you do the simplification, your expression is going to end up looking something like this. We are now getting rid of all the things that go to infinity. All we're going to be left with are things that are in terms of constants, whose limits we know exist, and other expressions in terms of 1 over x. Now, if I were to sneak a peek, I would see a 3 plus a 0 upstairs and a 5 minus a 0 downstairs. So I can use the limit laws because I know all of these limits exist. So I go ahead and I distribute the limits, and I do it in the proper way here. I put everything in terms of the 1 over x limit. When I do that, what you'll end up with is an expression that looks something like this. So since the limit as x goes to infinity of this function is 3 over 5, that means that there is a horizontal asymptote with an equation of y equals 3/5 as x goes to infinity. If you went through and did the work, and you did the limit as you approach the other side, you would find the same thing. So this function has a horizontal asymptote on both sides, but it's the same asymptote.